Hello everyone. Today's project is one of my earlier designs. I've been manufacturing and selling it for about a year. It has operated reliably, with a failure rate below 5%. I've now developed a newer version rated at 3 kilowatts, so I will share the complete design of this previous version with you. I would like to extend my sincere thanks to JLCPCB for their generous sponsorship of PCBs for my projects. Many of my projects would likely not have been possible without their support. I will walk you through the simplest way to order PCBs from JLCPCB. First, you need to create an account. You can quickly sign up using the link I've provided below this video. Then, upload the Gerber file that I provide. Once the Gerber file is successfully uploaded, you can perform a final check of your PCB using the built-in 3D viewer tool. This tool is extremely useful. You can easily identify design errors and preview how your PCB will look after fabrication. Next, you can select the PCB color, material, and various other parameters. After completing all the configurations, simply add the order to your cart and proceed to checkout. Don't forget to apply discount codes to optimize your PCB cost. JLCPCB is currently offering significant promotions for 6-layer PCBs. If you are working on 6-layer PCB projects, be sure to sign up and take advantage of these great deals. This is the PCB I received after 2 weeks of waiting. The quality is excellent with a smooth and glossy finish. It matches my design perfectly. I divided the board into separate functional blocks. This makes assembly and calibration much easier. Components that generate more heat are placed closer to the cooling fan to improve thermal performance, while other components are positioned farther away to minimize dust accumulation. I believe the assembly process will not be too difficult for you, as I selected components that are readily available at most electronics stores. In addition, all component values are clearly labeled on the PCB. Even if you are a beginner, you should not encounter any difficulties. One important note, solder fumes are hazardous. You should use a fume extraction fan with filtration, such as a damp cloth or activated carbon, to protect your health. I often use components salvaged from old equipment. They are very inexpensive, of course. Moreover, their quality is still quite reliable. Many new components on the market today are counterfeit. They may work well for the first few days, but can fail unexpectedly afterward. These two small boards are the most challenging parts of the inverter assembly. They are the 12-volt power supply board and the DC-DC control board. If assembling them is too difficult, you can purchase them directly from me. I have these modules readily available. The power supply board provides a stable 12-volt output for the cooling fan and control circuitry. The control board drives the DC MOSFETs and also monitors the output voltage, temperature, and battery voltage. If any abnormal condition is detected, it will immediately shut down the system and trigger an alarm. Once the DC-DC stage is completed, power on the inverter and carefully verify the key parameters: the 400-volt bus supplied to the H-bridge, the 12-volt rail, and the supply voltage for the control board. Check that the standby current is around 0.5 amperes. If everything is within specification, proceed with assembling the DC-AC stage. For the DC to AC stage, I use IGBTs for the H-bridge in combination with the EGSO02 control board. This is a well-matched solution. Moreover, they are low-cost and widely available, so you can easily source them from electronics stores. Finally, this is the completed product. For the initial test, you should use a laboratory power supply. It helps prevent damage to the device in case of a fault. If all parameters are within specification, proceed to test with a load. The efficiency should exceed 92%. If the efficiency is lower or the circuit heats up abnormally, immediately recheck the components.